I would like to say at the beginning is that this is a workshop. So it's not very formal. You can interrupt whenever you want. We will not stick very carefully to the program. I mean, we can speak longer or shorter, like let us free relax as much as possible. And the workshop has two parts, one which is more theoretical, and the second one which is fully practical. We would like to record also the practical part. However, be aware that we have just one camera, so this may not be so easy as we think it will be. And now, first thing I should explain is that this workshop is the workshop organized by the new research project, and the theme of this project is seen on the slide. And the project has quite complicated title, Exploring Textile Imprints on Clay from the 3rd and the 2nd millennia BC, Advancing Cutting-Edge Research and Documentation Protocols with Case Studies of Diverse Textile Consumption Contexts. So no wonder that we are using the acronym ExplorTIC to make it shorter. And now let us go to the program. Our aim is generally to work towards formulating best practices for the study of textile imprints. And to do that, we are going to take into account a series of challenges related to this very specific type of textile preservation. And the problems we are going to relate to during our workshop result from the very nature of the imprints, which are frequently poorly legible, and they are fragile. The impressed textiles are altered, both from impressing and also from firing. But there are also problems with documentation of this evidence, like practical problems, because these textile imprints are usually prominently three-dimensional. Therefore, like the digital documentation, which is 2D, is not the best to document them. And they could also vary in size from very small pieces to entire pots. And there is also the problem with the interpretation of what we see, specifically in the identification of raw materials and production techniques. But also in case of decorated pots, there is like the discussion on the symbolic and decorative meaning of the court ornaments, and a potential like communication potential for using quartz as like the means of communication, which we can also see in the sealing practices. So it's like interesting case study. And within the project, we'll start with the part in which we'd like to present the tools we have already developed in the ExplorTIC projects relating to the 3D documentation. So we'll talk about scanning, about structure from motion photogrammetry, and about RTI. And we would like also to evaluate the skills required for using these techniques. Would like also to discuss how these techniques are, how expensive is the equipment, and what is the time consumption of providing this type of documentation. And this will be presented by Marek Truszkowski, who is part of the team. And then would like to come to a very exciting evidence of textile imprints on human plaster casts from Pompeii, which is studied from Francesca Coletti within the Textiles Project. And Textiles Project is another project to which we'll be referring very much today, because it's like the parallelly running project in which textile imprints are also like the part of the case studies which are investigated by this project. And the last talk before the lunch break, we'll discuss the potential of SEM in the studies of textile imprints, and this will be presented by Aldona Kurzawska from Adam Mickiewicz University. Francesca Coletti is from La Sapienza in Rome. Probably you will know from her presentation. And SEM is something which was until now very rarely applied for studies of textile imprints, partially because it's difficult to put like entire pot under SEM. But when we have fragments, there are like new prospects, I hope, for the SEM studies. So this is something which we're also very much interested in that. And then we will have a very interesting talk by Maria Anastasiadou from the Corpus de Notion Mechanischen Siegel in Heidelberg, which is referring to the modern evidence of the plasticine impressions and silicon casts of seals and sealings from Bronze Age Greece collected over many years. And her like provoking title saying document them, analyze them, and then what? Will somehow apply also to the ExplorTIC problems, because we have already generated a lot of positive imprints, and it would be a great pity not to use them afterwards. And also we received today, I have to say, an impressive collection from Karina Gremer. And this is like her many years of studies on textile imprints, which are now handled to us, including everything, the imprints themselves, the raw materials, but also like her notes and reports and everything. So we are extremely grateful for Karina for this support. And this is indeed like the thing, what to do next. Like, I mean, this is like a valuable evidence. And finally, we will focus on experimental part of research on textile imprints. And here we'll hear about Karina Gremer experiments, which were conducted for many years now. I think you started, like you said, 2008, yes? So it's a long tradition of studies of textile imprints from different port impressed pots. And in the afternoon, we're going to have like the practical session. We are going to play with hands-on activities. We will apply different materials to make the positive casts, and we will also try to formulate the best practices for documenting them in general. So the main aim of the ExplorTIC project is to develop comprehensive research and documentation protocols for textile imprints on clay using digital tools, a reference collection, online repository, and dedicated databases. And the project is based on a newly compiled data set. We hope for over 2,000 textile imprints. Whether we reach this number, it's still an open question. But what we have documented by now, it's about 1,000 imprints. So it's already like a quite impressive number. However, part of this has been documented by my previous project, which was called Textiles and Seals. So for this project, we have like 2 case studies and the reference collection, then 3 methodological objectives, and we will focus today on methodological objectives, and 3 research objectives. And now talking about case studies, we have several sites from Poland with textile imprints, mostly on pottery. And these are so-called both ornamental and technical textiles. And from those a range of sites, what we have already done is the documentation of imprints from Wrocław Widawa site 17. And this has been done in collaboration with the Polish Academy of Sciences and the Institute for Archaeology and Ethnology. There are more sites that are that were excavated and researched by this institute. So our collaboration will involve more particular case studies. And Wrocław Widawa is the University of Wrocław. I'm talking about Kichary-Nowy site, to mix them. And from Kichary-Nowy, there's still like a few entire pots which needs documentation. but otherwise we are sort of like done with the basic documentation of these two sites. And the institutions with which we collaborate now are like the Polish Academy of Sciences and the Institute of Archaeology and Ethnology, University of Wrocław, and again, I'm giving credits to Wrocław Widawa site to this university, and then the Faculty of Archaeology of the Adam Mickiewicz University of Poznań, and then the Archaeological Museum in Poznań. But these are the institutions with which we sort of already settled up our collaboration, but there will be more museums and collections which we would like to study. And now the second case study comprises textile imprints on the backsides of place sealings that are studied in the collection of the Corpus de Notion and Mechanischen Siegel in Heidelberg. And the sites which were already examined are now listed on the map. And they're like 4 sites from which we have completed the analysis, and this is Katozakros, which was like studied also by Dr. Maria Anastasiadou, who is now with us, and it's not yet visible to the public, but it has been documented. And then Festos, Hiraki, and Lerna. Now, if we talk about research objectives, we would like to reveal the diversity of patterns and consumption contexts for textiles that are impressed on clay. So we are interested in their ornamental role on pottery. We are interested in cross-craft interactions. We are also very much interested in how textiles were applied in storage and administrative practices, including sealing practices. And we're also interested in textile recycling and reuse. And these topics can be studied for both case studies, so like the textile imprints from Poland and textile imprints from Bronze Age Greece. We also aim to trace potential individuals associated with specific textile products and specific sealing practices, and this is illustrated by the iconographic shown on the slide. So by examining and like bringing together the properties and qualities of the impressed textiles, we can discuss about the skills of individual textile workers who made those textiles. We can analyze site-specific range of impressed textile products and the level of the standardization. We can look for innovations and diachronic developments in textile technology. And we can also analyze these textiles according to their expediency for the attested purpose. And here we will go also for the collaboration with the Textiles Project, when we will have like the tests on by our partner, which is Fraunhofer company, and they will I will try to and they will make like the test on the mechanical strength of fibers and textile products, which we believe were used like in sealing practices for us well, so we can like try to estimate how expedient they were for the purpose, how strong these cords and threads were in fact. And then we also look for the manner of handling and the habitus for the individual, expressed by, for example, the numbers of wraps, the way how the threads were knotted, and how the loose ends were stretched and how they were looped. And then for the case study 2, we have like seals impressed on the front sides, which are also very important evidence. So originally we thought that this kind of research will be mostly applied to the case study 2, that is the sealings. But actually, we now see, after studying a lot of the evidence from pots, that it's possible to apply some of these questions also to pots, like the individual handling, the way how the ornament was applied on pots. We can also trace those individuals studying the textile impress pottery. And our third aim is to reveal local and regional longue durée developments and in textile technology and exploitation of natural resources. I will make a short break and I will try to make Nazar the co-host, so it will be easier to proceed for me, because otherwise. Okay, and now you're coming back to the presentation. Um, Talking about the methodological objectives, we'd like to focus on evaluating digital documentation and, let's say, analytical methodologies such as RTI, photogrammetry, 3D scanning, SEM, and would like to establish comprehensive digital documentation protocol and create standardized vocabulary and also manual for technical analysis. We would like to define characteristics, classifying impressed raw materials and techniques of production through archaeological experiments, and formulate best practices to address the key challenges in the study of the textile imprints, about which we will talk in detail today. And a few words about our reference collection, which is created in a close collaboration with the Archaeological Museum in Biskupin, which is quite renowned experimental center in Poland. And what we would like to say, like provisionally, is that we decided to create yet another reference collection, and now it comprises 20 raw materials produced in different techniques, so it's actually more than 20. We have documented 5 techniques of thread and cord making and 10 techniques of textile making. Now, I mentioned the collaboration and like our participation within the in the Textiles project, and our aim, like of the University of Warsaw in the Textiles project, is to collaborate towards creating the AI machine learning platform, which is called AMALT AI. And we hope that this platform will help us define whether my notable skepticism about the potential for recognizing raw materials based from imprints, because to me it's not possible, whether AI can do better than than I can do, or perhaps other people can do. And we also want to test like at 2 levels. First, we'd like to test it for actual raw materials, and then we'd like to test it for the raw material groups, which I have identified. And then we also would like to test how AI skills in recognizing the thread and cord making techniques for the beginning, because the problem with any AI machine learning platform, as I'm sure you are all aware, is that we need to produce a huge amount of the training data. And this was our activity at the end of November, when both teams of both projects were together in Biskupin, and we've been producing thousands of photos and hundreds of imprints. And the way how this platform is working is presented here with this like chart or graph. We have with us Dr. Nazari Buławka, so if you have any questions about how this platform would work, please forward them to him. But we are actually quite optimistic now about the potential of machine learning, and looking forward very much to learn about the results. And now, of course, we need to somehow integrate the data. We have decided to keep two databases because the scope of the data or records in the database textiles and seals is different from the one which we already produced for ExplorTIC project. The one for the ExplorTIC project is more extended. First of all, we are working based on actual imprints on clay and also their positive casts, whereas in the case of textiles and seals project, and like this case study with the sealings from Aegean Bronze Age, we deal exclusively with modern casts and impressions. And for the ExplorTIC project, we also include such aspects like ornamentation, which we try to encode into our database. So that one is much more extended. And actually, the reference collection will be created in the third database. So we will have three databases in this project. And we foresee that these databases will be integrated through the research engines, and it will be possible to, as a user, to use the resources in all three databases. So, for example, if someone will be interested in what we define as raw material group to see what is represented by this group in actual imprints, can go to experimental and data and reference collection. And if someone is interested how this type of raw material looks on the pots or on the ceilings or undersides of the ceilings, it will be possible. And our aim is to provide as much data online and in open access as possible for further studies, because we see a huge value in that this mass upload of new data will make a big step forward for studies of textile imprints, and it will also help to make these studies more comparative, because this is one of the problems which we identify now, that these studies are not fully comparative. And we would also like to present our 3D models online. For this, we use for the moment Sketchfab of the Faculty of Archaeology. So it's possible to see already the first photogrammetry results on the Sketchfab for the Wrocław Widawa 17 site. But in the final publication, we would like to find free software, not Sketchfab, because this is another aim of our endeavors, that every data which we publish online is not based, is published through the free software, not licensed software, and it's accessible fully to anyone who is interested to have a look at them. And now we are coming to the formulation of challenges, and I would like to divide them into the three groups. First is related to the evidence, second is related to the methods of research, and third is related to terminology which we use. So the evidence related are probably the most easy to formulate, and also there is nothing we can do about them. I mean, that's the state of the evidence. So again, it's poor legibility of several imprints, fragmentability of textile impressions. So if we have a part of a shirt, we don't really know what was the entire ornament applied to it, its potential fragility of the fragments, although some of the fragments are very well preserved, notable three-dimensionality, alterations of textiles in impressing, and then alterations of plyometrics. If we move to the methods-related problems, I think the biggest problem is the lack of standardized methodology and protocols, which makes the studies conducted by different scholars not fully comparative. The other problem is the subjectivity of interpretation. It's the lack of standards in identification of raw materials, and also lack of standards in identification of production techniques, and lack of standards in what I would like to define textile clay application techniques, because we do not talk only about textile products and their impressions, but also the ways how these textiles were applied on the clay. And in case of pots, sometimes they're like um, techniques which are quite complicated, and I will talk a little bit more about this soon. And then there are also problems which are terminology related. So we still lack standardized systems describing properties of impressed products. And this is especially visible when we look at publications like in national languages. For example, for Poland, there was a lot of publications in Polish describing textile imprints, but almost each of them use different terminology. So you're not sure whether we are talking, given the poor number of figures and photos, sometimes it's really difficult to understand what was the imprint, what we were talking about. So this lack of standardized systems describing properties is a problem. Then we also lack standardized vocabularies to identify products, raw materials, and production techniques, and this is also a problem. And then we lack the vocabularies for these techniques of application of textile ornaments, and I think this is something we have to develop like from the scratch, unless Karina has something to add. And if we talk about these challenges here, I'd like to illustrate my problem with raw materials. And you can see a lot of experimental imprints of different raw materials, and also their grayscale photos from Dynolite. And I found it very difficult to understand what specific features in the microstructure of impressed textiles were chosen to define the raw material, and how these identifications are secure. And what also troubles me is that when we talk about the identification of raw materials, we focus on the raw material and not on the technique of its processing, whereas the processing techniques could make fibers looking entirely different. So, for example, flax from like the dried stem would have a different microstructure in the imprint than flax obtained through retting and then pumped. So these are also the issues which I find problematic. And for the Textiles and Seals project, I developed a protocol taking several categories of fibers and trying to define what is the surface appearance, what's the microstructure, what's the section, if it's like preserve the ending of the impressed product, and what is the use word. And this made me to conclude that actually what we can talk about are the groups of raw materials such as long strands of fibers, broad strands of fibers, short individual fibers, long individual fibers, and then like fur or fur-like. I like very much use this term fur-like in whatever I define wicker and rush-like and leather-like pieces. And whereas it's the microstructure of products such as wicker, fur, or leather is really distinctive. And even though we cannot talk about any specific species, we can still like distinguish these products from the others. Whereas for the long strands of fibers, broad strands of fibers, short individual fibers, and long individual fibers, there can be many raw materials groups which give similar appearance. So here is the hope for the AI, but also a hope for SEM. So probably SEM will be a tool which will help to give more precise definition. As for the moment, we use this descriptive categories also for the material which we find on textile imprints on pots from Poland, so from case study 1, and it still works. So it's a kind of proof that this categorization has some potential, but maybe it will be possible to make it more specific. And another challenge is related to the documentation of techniques. And here you can see experiments made by Monika Kaczmarek, another team member, in impressing 2, 3, and 4 strand cords made of flax and lime bust on clay. And as you may see, like the recognition of how many strands were used to drill the cord is not so easy based on imprints, and 2-strand, 3-strand cords can look pretty much similar, so I would not dare to define which one is 2-strand and which one is 3-strand. And also there is like a good illustration of what I'm calling the terminological problem, because the term which is used like by Karina and also by us is drilling, but this type of cord is also described as twisted or plied, and then we do not know if we talk about the same technique or about different technique. And now we are coming to this problem of recognizing textile production technique or textile clay application technique. And it's illustrated by the fragment from Wrocław Widawa, site 17 again, but we know that this type of decoration, or maybe not even a decoration, this type of pottery treatment is, it has probably some aesthetic value, but let's call it like pottery treatment type, was quite popular in Poland. We find it from many sites. And the way how it is applied is not related like to a specific textile product, but to the way how the textile is applied on the on the pot. And here you can see the photo from our last workshop in Biskupin, where I'm trying to apply this kind of decoration using this kind of treatment, surface treatment, using a stick with wrapped cord around it. So how do we call this? I mean, is it like a textile product? The surface seems to be more complex, but we have this terminological problem, how to define products that look like that. So that would be all. We will have also some tips, but now I would like to stop for a moment, ask you for potential questions, and then we will move forward to another presentation. I think that we can mouse. Sorry. Are there any questions from the audience in person or from the audience online? Maria.
I saw that on the one hand, you are using the original data, for example, the vases with the imprints. On the other hand, you are using a lot the casts and impressions, for example, what we have at the CMS. So what I was wondering whether for the 3D or the AI, it would be better for you not to use the casts or the impressions that we have at the CMS. Now I'm talking about the specific collection, but the originals. And in this way, you could avoid issues that you have when you are, for example, at the CMS, where you say, this is not a good plasticine cast, I cannot see well. Whether if you went to the original, you would have all the data that you want imprinted in your 3D or in whatever.
Let me say again that for this multi platform, we don't think it will matter so much because the difference is basically in the twist direction. Yes, so the positive casts are reversed. So the positive casts reflect the twist direction of the original imprint, whereas the negatives reflect the reverse twist direction. And this is not something which we're like now trying to ask the AI about. And actually, the archaeological objects were twisted in both directions, which we called S and Z. So it does not matter very much. The point is that we really want to see whether the AI platform, the AI model, will be able to handle with the most difficult imprints. Because, like, I mean, with fine imprints, it's no fun to ask it. Yes, it's like we expect that it will be able to recognize raw materials quite well and perhaps even better than us. But my question is about like imprints with poor legibility. So if you ask me about like the TMS collection, then I would go for this really not well readable imprints, because this would be very interesting for me whether AI can help in that or not. And this is something I would like to address too, that this platform will be available for anyone in the future. So given that it works, anyone can check like the collection of their imprints and see what would be the identification. We're not expecting like 100% success in identifying raw materials, but if the identifications will be like correct for like 80%, we would consider it a big success actually. And if we fail, then we failed, then we tried and it's not working. Yes. Okay. Tool to make calls. Okay. Thank you, Margarita, for that comment. So this is another thing to think about, like what term then to use. I found drilling perfect term, but maybe we should come back to twisting. No. We will see. We will see. We will not make like. Okay, you haven't got the, but you're using samples for the loop textile. Yes, has been a lot of methods of not woven loop textiles themselves. Yes, many surface texture confusions. Yes, even in the textile, let alone when they are impressing clay and lose some of the dimensions. I cannot agree more to this comment. That's very true. Yes, I have to agree that you will see what we were testing in terms of techniques in the presentations by Magda Przymorska-Sztuczka from the Biskupin Archaeological Museum. But indeed, they're like looped textiles can be misinterpreted very, very easily, and we were aware of that. If there are no more questions, are there any more questions? Yes. Karina.
Yeah. No, I think the problem with terminology is, of course, because we all come from different languages. I'm from German, Francesca Coletti from Italian, you're from Polish, and then you just try to find any term that seems to be used by also native speakers. And also if the native speakers use different terms, and especially they use different terms if they are trained in prehistory or ethnography or classical studies. And I think that the best is just to look at what is the most used term, and then you just use it, and then you make a definition with drilling or playing or twisting, which we think is the same or is maybe not. We mean that, and with an image, and then you just use it, because all of these terminological problems are just language based, and everyone tries to do the best, and whatever this person reaches out, ethnographic studies or prehistoric studies, then they try to use the best and just define it and make an image what you mean with what, and then people can just mix and match with the image what looks like that this term is used. Just make it as simple as can be.
I think it was a very important comment, but still we would probably like to aim at the most accepted terminologies and more accepted terms, because I think it would make a lot of sense that we use the terms which are like most meaningful. And yes, of course, we are thinking about producing a vocabulary, illustrated vocabulary. So we will have like the illustration of the technique, and that's it. But otherwise, yeah.
And maybe for the illustrated vocabulary, you also mention the variants of of terms that are used for maybe the same. Yeah. That means twisting, plying, drilling are used more or less equally, and we use that. But always mention the variants, please. And maybe we can also use add some of the most important languages: Italian, French, German, Polish, whatever. What is the term there? Because sometimes if AI is working and translating things, that's the worst. If scientific articles, for example, from me in German are translated automatically, whatever AI will use for this, we don't know. But and that's what my German term is, would be also quite important.
I will just make one comment because we're not using the language models for the AI. So this will not be like this problem. So it will give the results according to the terms we will train it to use. It's not like base ChatGPT or whatever. No, these are like different models. So this problem is solved. But indeed, we should like be consistent using certain terms, and we would perhaps like to promote using certain terms to make the study of textile imprints more comparable. That's true. And here we have a comment from Mandeka saying that many of languages do not necessarily have the differentiation, and that's very true. And look, textiles have this issue, some languages differentiate between knitting, crochet, and nail binding, and others not. And that's very true.
Okay, it's a very short question. I was wondering before that you were speaking about the AI, and you spoke about you do not expect it to be able to be much help to you. I do not expect it to be able to be much help to you. But you expect it, I think, to be much help maybe to other people that do not know textiles as you do. No, let me. I think I want to. You referred to you expect it to help, or you want it to help when it's very difficult to identify what a textile is. Means when if it does this, do we believe it? Because then we will have to believe it. So you cannot or. So it tells me something. So what you're going to do is you're going to feed in all this data into a machine. It will learn how to identify them, and then it will identify something that you cannot identify or I cannot identify as that. Then do we believe it? Do we take this answer that we get from it as it's a fact?
This was also a very good question. So I try to repeat it. This AI platform, Amalth AI, is directed towards like textile heritage specialists, not like people from, I don't know, general audience, because I also believe that not so many people from general audience have collections of textile imprints on clay to study. So the answers which we are going to receive from this platform is definitely directed to the specialists. And now I told you about the percentage. So we will test with the training data how secure the answers are. And this is what you have to accept, that if the security for the training data is 80%, you may expect a similar security. Maybe there are like, Nazar would tell that if there are like calculations to adjust this success rate, let's say for the original data, but we will receive exactly that. So we will receive the information, how secure are these identifications. So that's how it will work. I don't know if this answered your question. Okay. Nazar, would you like to make a comment on that, or?
So I understand your question was whether if the AI would recognize something we don't know, if we should trust it.
Yeah.
Okay. Okay, so I would think because this approach that we are trying to develop is based on the idea of using the experimental research. I mean, the experimental textile imprints, which means that we would be able to first have some basic idea what we're doing, like excellent specialists here in the room. And then the AI would basically be able to detect if we provide clear context, like for instance, the specific technique or material, then we can evaluate if this AI can actually answer the scientific question, whether it is, for instance, flax, or it is wool, or it is the other raw material or technique. But since at this moment we are using mostly image recognition techniques, I mean computer vision, which solely based on detecting or recognizing things that we are trying to detect. They are not large language models which can hallucinate. But I believe that in some short perspective, we can also work on this other, ideas that using large language models, then we can have these questions like we should trust it or not. Of course, typically in computer vision, we have some sort of a precision threshold, accuracy threshold that we can trust or not trust the results. Like, let's say 70% or 80%, if it's flax, cotton, wool, so on. I don't know if this still more or less what you was trying to catch up the questions.
Okay, so I will skip the introduction because Agata made a very nice introduction to what I'm going to speak about. So as title clearly states, I will be talking about 3D scanning, which is in our case, we are using only structured light technique. I will be talking about structure from motion, which is a photogrammetric technique. And I will be talking also about reflectance transformation imaging, which is, for instance, photographic technique. During this presentation, I will try to describe each method individually. I will try to talk about the process of creating, but I will be focused mostly on the approach that we are having in our project, because we don't have time to speak about all the method, because the methods are complex. So I will just focus on the approach that we have in our project. I will be also try to speak about possibilities of each method, about results, what data we are creating, how to visualize them, advantages and disadvantages, and of course also about the equipment and requirements we need. But before I will start talking about each method individually, I think we need to organize some basic information. So with those three methods, we create two types of data. We create 3D models, the 3D data, which we created with 3D scanning, obviously, and with structure from motion technique. And with reflectance transformation imaging, we creating only two-dimensional data. So we are dealing with images. We can create very interesting results, but still it's only two-dimensional data. Before we start, I think we need to also understand what a 3D model is, because it helps to understand how each method is working. So basically, 3D model is a digital representation of an object created using mathematical data that defines its shape, surface, and sometimes its behavior. And for us, the key component of 3D models is geometry, because as you all perfectly know the essence of working with the 3D imprints is to know the topography of this imprint. So we need to recreate the geometry of the imprint as much detailed as it possible. So this is the essence. And geometry in 3D modeling is usually made of mesh, and mesh is consisting of vertices, edges, and faces. So to create a 3D mesh, you need some single points in the three-dimensional space. Every point is described with three coordinates: the X coordinate, Y coordinate, and Z coordinate. And those three digits are defining where the point is in the 3D space. When you start to connecting points with lines, you create edges, and when you fill the empty space between edges with some surface, you create a face of an object. So with these 3 components, you can create a 3D mesh. And with this small amount of data, you can create very simple shapes. But if you want to create more complex shape, you need more data. You need more vertices, you need more edges, you need more faces or polygons. So it is very important information for us in our project, because we want to create as detailed model as possible. Yeah. So we need more enough amount of data to create very complex shape of the topography of the imprint. So at the beginning, we need to be aware that we need to create a lot of the basic information. This we need to have as much points in our model, in our point cloud, to create complex geometry of the imprint. Because when we don't have a sufficient amount of data in our 3D model, we won't be able to create complex geometry of the object. So this is the basic information, that our data need to be very good quality, and we need to have like a lot of points in our 3D model to create complex geometry of the imprint. And next component of 3D model is texture, because with structure from motion technique or 3D scanning, we create models with texture, with photorealistic texture, but all of us need to be aware that we always can turn off the texture, because sometimes texture is not helping in analyzing the shape of imprint, the topography of imprint. Because, for example, on this part of pottery, of vessel, in the areas where it's darker, sometimes it's difficult to see the shape of the imprint. So when you turn off the texture, you have only like when you are watching only geometry in one color, sometimes it might be easier to recognize some details of imprints. The first technique is 3D scanning, and there are many 3D scanning techniques. There are many devices. There are many types of 3D scanners. I won't be discussing each of type of scanners, because it's not part of this presentation. But we need to know that the structured light scanners, the scanners that we are using in ExplorTIC project are non-contact scanners. So we don't have any physical contact with our object. And how this technique works. So we have the device, 3D scanner, which have built-in projector and sensor. Projector projects light. So this is in name of the technique. And it also projects known to the scanner structures. And those structures are straight black lines on white background. And if this structure is projected on flat surface, the lines is straight. But when we have some object on the way that have some geometry, the lines start to shift. They change their shape. So sensor in our scanner is recording structure. It's recording known to the scanner pattern, and if it see that the shape of this pattern is changing, it can reconstruct the 3D geometry of the object based on the shifts of the black lines of this known structure. There are many types of structure light scanners. There might be very professional, very precision scanners, but they are also very big. They might be very expensive, and some of them are not very mobile. And mobility is very important in our project. So we are using small scanners, let's say semi-professional scanners, which are the type of scanner that is visible on the lower picture. They are very small, they are very mobile. You can put it on desktop. They have a turntable, so you just put object on the scanner, and the whole process is almost automatic. So you just use the software to create 3D model. So it's very convenient, very easy for us to create this type of documentation. And as a result of scanning, the scanner creates, first of all, it creates the point cloud. So the structured light scanners might be they are very good in documenting the overall shape of an object. It creates a lot of points. The point cloud is very dense, and we can create, from this point cloud, we can create very good 3D model. We can create very smooth 3D models, very smooth meshes. But the type of scanners that we are using, they are not very good for documentation of imprints itself. It's very good to document the overall shape of vessel that we are dealing with, but not for impressions. So we are using this technique only to make documentation of whole forms, like whole vessels, just to show where the imprint is on the vessel, because it's very nice to show the location of imprint on the vessel using this, using 3D models, using these techniques, but not so good for imprint itself. It's also very good because this method is very precise. So we can make measurements from the vessel. We don't have to remember about taking every measurements when we are working in different institutions, because we are working in many museums, we are working in many universities. Sometimes you just forget to take some measurements when you are working in this place, and you can make all of the measurements from a 3D model. So it's also very good for our project. So for this technique, what equipment do you need? So of course you need to have a 3D scanner, and like I told, there are many types of 3D scanners. They might be very expensive, but also they are big, not mobile. We are using the smaller ones, and the cost of this small mobile scanner is around 1,000 to 3,000 euros. You don't need any additional software because software is included in the price of scanner, and you need some computer, laptop or personal computer to work with 3D data, of course. But I'm not talking about prices because everyone has different computer. It don't have to be very strong computer, but it also can be very weak computer. So like normal office computer should be enough for working with those type of scanners. What are advantages of this method? First of all, it is very precise, and you can make measurements from the 3D model. It's very good for capturing the overall shape of the object, but not very good for impressions. It's also capable of scanning very complex shapes. It's really easy in use. When you are using this desktop scanners, the whole process is automatic, so it's really easy to use, and no extra skills is needed for this documentation. It might be affordable, and it is mobile. So this is the advantages. This is the things that are important in our project. Disadvantages is the low details. It's not good for imprints, and it has problems with shiny and dark and transparent surfaces, from which dark surfaces is sometimes problematic for us. But usually we don't have any problems with scanning pottery. The documentation time took around 10 minutes if you are working with a fully automatic mode. But if your object is bigger and it's not fitting into the scanning area of the scanner, sometimes you have to manually move your object, and the time gets, you need to spend more time to move object, and if it's very complex, sometimes you need to spend 1 hour just to scan one object. Training time needed to learn this technique, I think 2-3 hours would be enough to show how scanner works and how to work with software. And it's not very complex. The method itself, it's very easy to create 3D scan. Not to work after that, but to create 3D scan, it's really easy. The data, of course, you are creating 3-dimensional data. You can export data into most common 3D formats like OBJ, STL, PLI, FBX. Yes, so you can export your data, whatever file format you need. Typical project in our ExplorTIC, typical scanning projects take from 200 to 400 megabytes on your hard drive. The more complex projects take more than 1 gigabyte of data. And as for visualization, there are many free 3-dimensional programs to visualize data. So it's very easy to find them in the internet. There are also many 3D online viewers, so you don't have to install any software on your computer to visualize 3D data. You can just type in browser online 3D viewer, and you will have a lot of online 3D viewers, also free viewers. You can publish or share 3D data on your website. You can put 3D viewer on the website of your project, of your institution. So it's also very nice to visualize your data. And you can also render some animations or 2D images from your 3D data. But here you need to have some experience with 3D graphics. You need to spend some time to learn this. You need to learn how to create this type of animations. So second technique we are using is structure from motion technique. And structure from motion technique is a photogrammetric technique. So it's very popular in archaeology. It's not used only for to create documentation of single objects, but also for trenches, for archaeological sites. And in archaeology, if someone is saying that he's creating photogrammetry, he's using structure from motion technique. So this is the more precise term of this technique. This technique works by analyzing the series of overlapping photographs. So you need to create 2-dimensional data, images, photographs, to put into the photogrammetric software, and on the basis of the photographs, software recreates 3-dimensional shape of object. And the photogrammetric software mimics human vision, how we perceive reality. Yeah, because as you all know, we see each eye see a different image, and then brain is connecting this image that we can see things in 3D. And photogrammetric software, structure from motion software, works the same, but it's not using 2 photographs, but many photographs. So thanks to that, it can reconstruct the 3D geometry of object. And name of this technique comes from reconstructing structure of object from the motion of the camera, yeah? Because camera need to change its position around the object. So how we create this type of documentation? First of all, we need to capture images. We need to create photographs of object, and those photographs have to overlap each other. the perfect overlapping area is around 60 to 80% of overlap. You need to create pictures from different angles, and it's good to have consistent lighting of your object. Key rule: the more photos, the better the result. Right now, I will change this to more good quality photos, the better the result, because you need to remember that photographs need to be good quality. They have to be sharp, because if you have blurry areas on your photographs, the software will have problem to reconstruct the geometry. So it should be, there should be very, very sharp. Yeah, on the, we can see the overlaps, the overlapping area of photos are shown on the bottom of our slide. So we have series of photos, and on the first photo, the red area shows the red square shows the area which is also visible on the second photo. The yellow square shows the area which is also visible on third photo, and green square shows where the area which is also visible on fourth photo. So we see that when you are making photograph, there should be in there should be making in order to be very the overlap should be very fluid. The second part of creating this documentation is what the computer is doing. So the calculation. The software is searching for unique points, unique features on your photographs, and it's analyzing every photograph in your set. And after that, it tries to connect those photos based on this unique features. Software itself, after that, try to recreate the position of camera when camera was in the moment when it was taking picture, and also it's try to compute the coordinate of each point. And in result, in the first step, the program is creating point cloud. So every single point that was detected on photographs and it was connected throughout each photograph is put into three-dimensional data, and it creates very, very dense point cloud. On the basis of this point cloud, you can create 3D models. So you create after that mesh, you connect points with edges, you fill with a surface, and after that you can put texture on your 3D model, and in the result you have textured 3D model. And the whole process is automatic, so you don't have to worry about how to connect those things. You just tell software what to do, and software will calculate everything throughout this process. And like I told, this method is very complex. It's used in different areas and also in different industries, but in archaeology, you can make a lot of types of documentation with a structure from motion. And the approach that we are having in ExplorTIC is that we are try to use decent digital camera. So we use DSLR or mirrorless camera that it's good quality, that creates good quality photos. And we use wide angle macro lens. Macro lens because we are dealing with very small objects. We need to be as close to our object as possible, because we need to create the geometry of very, very small, very complex thing as the imprint. And why we use wide angle lenses? Because we need to be close to the photograph object, because with normal macro lens, you have to be far away to get every area in focus. But with wide angle macro lens, you have more area on in your photograph, and you can go closer to your object. The problem is that wide angle macro lens create distortion of the geometry. So how we are dealing with this? We are dealing with calibration every set of photographs. So before we start to calculate, before we start to make photographs, we make photograph of calibration pattern. So this is the black and white chessboard. So when we have our camera in fixed position, when we catch the good focus point on our camera to create photos of our object, then we make photographs of this calibration pattern. We put it into software. Software can calibrate this particular setup of camera, and after that we can create a good geometry of the object. So this is our approach. And we also don't move a camera around the object. We put camera in fixed position, and we move object under the camera. This gives us opportunity to create this calibration, because when we have camera in one position, we don't change it. We don't change the position of lens. We can make calibration, and after that we can create good set of photographs to our 3D model. And we also using approach taken from aerial photography, that we are making strips of photographs. It is visible on this upper image. We are creating strips of photographs, and of course every single photo in this strip is overlapping with each other, and also strips, each strip overlap with a strip that is near to each strip. So it's approach taken from aerial photography. What are the costs of this method? So first of all, you need to have good digital camera, decent digital camera. I write 1,500 euros for a good camera with a macro lens, but of course, in photography, sky is the limit. As much as you want to spend for good quality camera, you can spend as much as you have. Software. There are many photogrammetrical software. There are free options, which might be good, but sometimes working with free software is not user friendly. But of course, you can use this type of software, of course, and you can also use commercial software. We are using software that costs around 500 euros for educational license, and if you will want to buy a commercial license, you will have to spend around 3,000 euros for this type of software. You also need to buy some photographical accessories like tripods, stands, lights. So it is cost from 500 to 1,000 euros approximately, of course, because again, you can spend as much as you like, and of course you need a computer to calculate this data. What are the advantages of this method? This method is also quite precise, maybe not as precise as in measurements, not as precise as 3D scanning, but still it might be very precise if you calibrate your model correctly. It's very good for capturing overall shape of the object, but also very good for capturing details. It's also capable of scanning complex shapes. It can be affordable, and it can be also very mobile. So, what is very important for us. Disadvantages: it's more difficult method than 3D scanning. It's good to have some abilities to organize photographic studio, and it's also good to have some experience in macro photography to create this type of documentation. Documentation time take from around 10 minutes to take photographs. and half an hour to 1 hour of processing of the data. And training, it depends. I think 2-3 days of training is required to know how to create good quality 3D models. Method complexity, in my opinion, is moderate. It's not very easy, but it's also not very complex. Data is the same as data and visualization actually is the same as in 3D scanners, so I won't be saying this again because you create the same data. You create 3D models, you create 3D data, so you can visualize in the same way. And disk space in our project, typical projects take around 1 gigabyte of data storage. And last technique is reflectance transformation imaging, which is a photographic technique. This is technique for capturing and digitally processing of the images. And it is used to record the surface of the object. And thanks to dedicated software, the dedicated software enables you to interactively move the position of the light. So it enables you to relight your object on your computer, because as you all know, if you want to create good photo of imprint, you need to work with your lighting. So you have to manually move your lighter to create the perfect position of the light that shows details very well. But with RTI, you can do it virtually on your computer. So it gives you the opportunity to move your light virtually, and software also have some built-in, let's say, filters for photos that enables you to create very interesting results. Sometimes it gives you a possibility to show details that is not visible on normal photograph. Those filters are might be very helpful in showing details. And how the method, how you create this type of documentation. So there are 2 approaches. The first approach, let's say classical one, it's to create this type of documentation, you need to have only a digital camera, very simple accessories, and specific light conditions. So you need to have dark room or some dark area without any source of light. You put your camera in fixed position, you put your object in fixed position, and the only thing that is moving is the source of light. So you create also a series of photographs, and each photograph is with the lighting in different places. And after that, software calculates those photographs and it gives you opportunity to play with the light in the software. And the whole technique is it's free to use, it's open. You can find how to create this documentation on the website visible in the slide, the culturalheritageimaging.org. They have software manuals, very good description how to create this type of how to create RTI. The second approach is to use RTI domes. RTI dome are devices actually it's hard shell on the top of which you can put your camera, and inside of this shell are point lights. This is LED diodes, and you have also controller, and controller controls the light and your camera. So simply say, just to simply say, controller lights one LED. It tells camera to create photo. After that, turns off this light, turn on another light, take photograph, and so on and so on and so on. And you can create the series of photographs with different lightnings. And this method is extremely easy because the only thing you need to do is to set focus on your object, and that's all. And the rest is made by the controller of the dome. So it is also very good to work when you are going to different institutions, because usually they don't have photographical studios, they don't have dark rooms to create this type of documentation, but with the dome, you just put dome on top of your object and everything is there. The light conditions, the lights, camera, so it's extremely easy. After you create photos, you process them in software, which is free, and the result it can be viewed in also dedicated software that is called RTI Viewer. Software is also very easy, but it can create very interesting effect. With the software, on the left side, you have image of your object, and with this green circle, you can move the position of the light, which is instantly visible on your object. So you can find the perfect spot to show complexity of your object and some details. There are also menu to choose from different filters. Filters are also adjustable, so you can move scale to work with the intensity of the filter, and thanks to that you can create very, very interesting results. The equipment you need to create this type of documentation is digital camera, which starts from 1,500 euros approximately. And if you want to use RTI dome, you need to, of course, buy this equipment, and the cost of domes are starting from 2,000 euros. And despite how big dome you want to have, the more expensive it will be. Software is free, and accessories cost from 100 to 300 euros. This method, like I told, it's very, very easy. And with the dome, it's extremely easy. It's very good for capturing details of object, and it is mobile. Disadvantages is the availability of RTI domes, because there are any shops that you can just go and buy RTI dome. They are custom made. So first of all, you need to find someone who will create this dome for you, and it's not very easy. In Poland, it's not easy. It is very hard to find someone who will create this type of device for you. The other disadvantage is that this method is actually quite old, because it was introduced to the audience in 2001, and it's not being developed. So the software has some bugs, and computers are changing, the operator, the systems that worked on computers are changing, but this software is in a state position. So I think in a couple of years that it will be probably impossible to use this software. So this is I think the biggest disadvantage of this method. And there are also no measurements. You can't measure any distances with this method. It's only for imaging. Time processing, time consumption is around 5 minutes to take photographs and 5 minutes to process data. So it's very quick, and it's I think I write 2-3 hours of training, but I think even 1 hour of training with the dome will be enough to show how to create RTI files. The usual project take around 300 to 400 megabytes of storage space, and visualization is only through RTI Viewer, so only from this software. There are any official viewers. There are no official online viewers for this type of documentation, so it's also a disadvantage. And the data that is visual, you can create 2-dimensional images as snapshot from the RTI Viewer. So this is how you can visualize data. And actually, I think it's all. Thank you very much.
Now we can open the discussion. I see. Are there any questions?
So thank you very much for your very interesting presentation. I really learned a lot, and it was very clear. One question as regard the photogrammetric technique that you described. Would you have a preference as to the SLR or mirrorless camera?
No.
If you say no, why then a DSLR? It's very heavy except if you have it already, then why a DSLR? And then you don't just say mirrorless.
I think it depends on the preferential that you have. If you like DSLR camera, use DSLR camera. If you like mirrorless camera, use good quality mirrorless camera. Now it's actually there are very good quality mirrorless cameras, so with very good optics. So I just write DSLR or mirrorless camera because someone preferences are DSLR, someone preferences are mirrorless camera. So that's all.
And there is a question on a chat from Calliope Sari. Poppy?
Hello, everybody.
Yeah, so
Thank you so much for this presentation. It is really promising. But we all know that the reality in the museums is somehow different. And my question is whether there is a possibility to approach the third dimension through photogrammetry. Is there a calibration method to approach old publications where you just have one black and white and perhaps a little bit blur picture, because the material could be very far away, perhaps it is not accessible, and sometimes we need it for comparisons or studies. So is there a possibility to approach this kind of methods to evaluate and old bad photographs? Perhaps there is a calibration method. This is my question.
I think it will be very big problem if you have only archived photos, and if you have only one photo object, you can't create three-dimensional data out of it. Even if you have a series of photographs, but it's blurry, it's bad quality, it will be very difficult. So I think it will be impossible to create three-dimensional data out of this photographs.
can you hear me now online?
Yeah.
Yeah, great. So we have two mics. Okay. Finally.
Thank you.
Is there, and then do you have more questions, Poppy, or?
No. I just wanted to be sure that that it is impossible to use these old photographs.
Yeah. You need to have enough good quality data to create good quality 3D model. So if
Yeah.
your photographs are, if you don't have enough information from your photographs, you can't create good 3D model. So if you have only one photograph, it is impossible to create 3D model. You can create 3D model from the scratch in 3D software photogrammetry, in 3D graphic software, but it won't be a copy of the object. It will be your impression of the object.
Okay, thank you very much.
And in chat, we have question from Margarita. Have you only completed different techniques for pottery impressions, or also, for example, carbonized textiles and mineralized textiles? And we were working on the latter two types in Padova, and have not yet tried RTI, but structured light scanning and photogrammetry seem to work well. Now we didn't as yet.
No, but I think RTI technique gives you different effects. So it might be very interesting to use RTI also for this type of objects. So for photogrammetry and 3D scanning gives different type of data. Okay.
So my question is more technical. How big, how small it can be? For example, for me, most interesting are mineralized textiles, but they are most of them are very small. And how I can do with 2 to 5 centimeters mineralized textiles and photogrammetry? How many pictures I can do? Because in my opinion, in my experience, I can just do 1 photo and that's all. Maybe 2, yeah, exactly. And if it's still possible to prepare photogrammetry.
Yes, that's yes.
Yeah, very, very big, but most of them are much smaller. Yeah.
Yeah, you just you need to create more photos, but from different angles. You the idea is if you want to reconstruct geometry,
Yeah.
you need to photograph the same object, but from different angles. So you can create, I don't know, 20, 30, 50 photographs of the same object. Yeah, but no, different angles. And thanks to that, you can recreate the geometry. The overlapping can be very high. I thought that 60 to 80% of overlapping of the photos is perfect, but if you have 99% of overlapping because your object is so small, you will be also able to create a model, but you need to have.
Okay, so 1 on top and 4, for example.
For example, yeah, or in. Because I understand that we are also trying to reconstruct on one surface. You don't want to reconstruct full object.
Yeah.
So you can put camera in fixed position, looking straight down, and I don't know, put object on some parts, or for example, yeah. Let's say put object on some card and move around under the camera in the. Like in industries, you have a camera facing down.
Yeah.
And you are making 1 photograph, second, third, fourth, fifth, 7th, 10th, 11th, and so on and so on and so on. It will be seen geometry from the different angles.
Yeah. Okay.
So it will be able to reconstruct.
Yeah, and 2 to 3 days of training.
No, it's 5 minutes. It's pretty simple, but the problem is with the size. Yes, and when you have so small text size, in 1 photo you have all of this. Even if you are using macro.
Yeah, but
Camera. Yeah,
And also,
Yeah.
so maybe, I'm sorry, but maybe Margarita can share about this, because they are doing things part of mineralized textiles and carbonized textiles. Margarita, can you like say how big fragments do you have? Do you have like super small fragments which you?
Yeah.
Yeah,
Sure, it's super small.
Yes, hello everyone. We are working with pretty small fragments when it comes to mineralized material, so we're talking just 2-3 centimeters across. For the carbonized materials, it's slightly bigger, but some of them are also quite small. And we have a challenge because some of our carbonized material is flat, so textiles, but with, for example, embroidery, and others things like balls of thread. So we're trying different ways of visualizing them and also documenting them because they're extremely fragile. So it's also a way of preserving, hopefully for the future, the information that we have about them. But it's still very much experimental. We've tried it on a few finds. Now we're trying to see what works best. And we would like to try out RTI to see how that compares to the other 2 techniques.
We can borrow you a gun.
Thank you.
Hi, are there any other questions?
So I wanted to ask you about the reflective scanners. Whether you said that you are using a mobile one. I was wondering, and that it cannot record the detail that you want in the impressions. I was wondering whether whether there are video scanners, maybe one that are not mobile, that do have the technology to record the tiniest details that you want the people in.
To be honest, I don't have experience. I'm using the scanners, like the semi-professional scanners. We have also more professional scanner that is bigger, but it's not also not enough to create reconstruction and geometry of textile imprint. But there are, of course, so even more expensive than the bigger scanners, and I don't have experience with those. So unfortunately, I can't answer this question.
I can only say that we made it. Okay, I will just comment because it's like that question. I think that we made like the comparison of scans which was taken by Stefan Bauer in Heidelberg with those which we took with this like the most professional scanner we have. And they are very similar. So both are evaluated by us negatively because they do not have they do not provide enough density for rendering the microstructure of textiles, unfortunately. So, but we know that there is also the new generation of scanners. So perhaps in the future it will be possible to use scanners, but from our experience, so far experience, the experience is rather negative for rendering the microstructure. And there is a question on the chat from Camila. How about focus stacking?
If you are using microscope, yes, this is one of the approach that you can make, but it's also not good for. It consumes a lot of time, so you need to. In general, you will have to create calibration for each photo, create a lot of photos to create one fully focused image, and it is very time consuming. You can't create this type of documentation when you are going to different organizations when you don't have enough space for creating good quality photos. So we haven't tried it yet because in our case, in our project, it's not we can't organize this type of documentation when we are in a different museum, in this different organization.
I tried not to do this focus stacking with, but it was a very, very expensive microscope and it's not mobile, and we just could do it in the museum, and we tried to document Court Fair, and it was really a very nice result to see also the microstructure. It was of course way better than any Dynolite or whatever, but it's complicated. You can do it, you can use it, I think go for it. Yeah, and I think it's there are now so many possibilities on how to get at least 3D or 2D photos. I think go for it to try everything what you can, and then it would be quite interesting to have from one sample try different methods at each institution where you are and what you have access to, and then just decide what is the best way. We can see, especially the tiny details. And so this is just my thing on that.
This is actually what we did, and so the publication is forthcoming. Because really, it was again for the Wrocław site 17, it was possible to document it in all possible methods, and we tried to compare its methods. So like briefly, the results are like that it depends on the artifact. So actually, it's not method based, it's like the find based. And I think sort of obvious. So, we cannot recommend one best method. We can just recommend that best method for this very specific point. Sorry. Okay, now if there are no more questions, then we will go to the presentation of Francesca Coletti. Francesca, the floor is yours.
First of all, I want to thank you very much, Agata, and all the organizers for taking part in this workshop. And so I hope to add interesting elements to the discussion, sharing my experience. So during my PhD research, which was focused on the investigation of all textile evidence found in the Vesuvian area, and I think most of you know about that, I have been dealing with carbonized textile, but also cast made for negative imprints using a custom medium. So the well-known human plaster cast of the victims of the Vesuvian eruption in the 79 AD, which were exceptionally well realized using liquid gypsum. So one of the famous directors of the archaeological part of Pompeii in the 19th century, called Giuseppe Fiorelli, developed casting techniques that still involve pouring liquid gypsum into the voids left by the body after decomposition. The fine ashes that covered the bodies during the eruption allow the formation of highly detailed imprints still visible nowadays on the plaster cast surface. In this case, the casting techniques conceived to give materiality to the body of victims unexpectedly revealed excellent details of garment, accessory, and textile structure. So documenting and recording the textile imprints wasn't easy. They need to be recorded with precision and in connection with the bodies, which was impossible with microscope and usually time-consuming and demanding with a digital camera. It was necessary to face several challenges arising from factors related to the body's shape and the surface characteristics due to the casting medium used. The primary challenge is studying negative textile imprint through modern casts arise from their inherent characteristics. In these, modern casts are made from different materials, for example, plastic and silicone, which carry a risk of breakage, and gypsum casts, which are the ones from the Vesuvian area, can be studied as actual three-dimensional textile remnants, but have fragile, shiny, and glossy surfaces. And also, the actual imprints no longer exist because they are destroyed during the removal of the ashes during the cast. So as you can see on the slide, the challenges encountered in documenting and studying the human plaster casts are related to the fact that they are heavy, large, and non-movable objects, white low relief casts of complex and low-scale textile structures. They are fragile, shiny, and they have a glossy surface with numerous shadow areas due to the body shape and multiple textile folds, destruction of the actual negative imprints, as said, and the reshaping of some plaster casts after their realization to enhance anatomical details, garment, and accessories as well. So it was necessary also to face with this last issue, and then to be able to, let's say, identify the actual imprints from the fake one. So the comprehensive studies of all human replicas allow us to collect extensive information about the garments and accessories used by the inhabitants of Pompeii and the surrounding area before they died. Some of the plaster casts were stored in the deposits, after were on display at the entrance of the archaeological park, others were still in situ inside the park. So this aspect was also challenging in the documentation, especially under poor light conditions, as you can see on the slide. For all these reasons, we also decided to apply 3D laser scanning in collaboration with the Rice Angular Centre for Archaeometry to some key studies. I will show you in a moment. Although the scanning performed with AFDEC EVA was not sufficiently high resolution to record the imprints related to the textile structure, it enabled better investigation of garments and their faults, as well as the faint presence of accessories. On 40 plaster portion of clothing were identified, with 28 preserving details of textile structure. Other garments like mounted cloth, tunics, undergarment footwear, and accessories such as belts, shoes, and shawls were identified. The graph on top right of the slide shows the remarkable variety of number of garments and clothing elements we identified on the body. Below are several examples of them with indication of the find spot, and what is remarkable is that we also encountered evidence of shoes. Remarkably, the sandals you can see on the slide, bottom left, found on the victims of the Casa del Cryptobaltico, partially preserved the open-nailed soles. These are the first open-nailed sandals of this type found in the Mediterranean region. So this evidence is critical and contributes to enlarging and obtaining a more comprehensive picture of the use not only of garments, but also of shoes in the 1st century AD. And of course, the inclusion of metal element in the plaster cover was of great help then to understand better the type of sandals. So one good example of garments we identified on the Pompeian victims is the one on the body of the 4-year-old child found in the Casa del Barciale d'Oro. This is one of the cases in which we decide to perform 3D laser scanning of the body. The 3D scan allows the virtual investigation of the cast. It was possible to move it within a virtual environment, appreciating some of the garment's most important details that were not visible to the naked eye during inspection. Indeed, the 3D prototype, coupled with the adoptive investigations, allow us to recognize two interesting features of the costume. The first one is the presence of a fabric belt fastened with a leather buckle around the waist. And the second one, as you can see in the central image of the 3D scanning, is the presence of a knot, whose function was probably to fasten and adapt the tunic on the child's body, making it larger or narrow as needed. On the slide, you can see an almost identical type of garments on the north side relief of the Arab ashes. So, as I already mentioned, however, in addition to clothing elements, the surface of 20 body preserved imprints of fabrics, in most cases with a very high degree of detail. On the slide, you can see the victim found in Casa di Castricio wearing a tunic whose heavily folds are still visible, and the quality of textile imprints is very remarkable. So the surveys and documentation of the cast were conducted in 2 phases. Firstly, casts with visible traces of clothing were selected and simultaneously mapped and documented on paper and with a digital camera, equipped with a macro lens to produce digital photographs of the areas of interest. Secondly, visual examination enabled the identification of textile imprints and the preliminary quantification of warp and weft thread counts. The analysis of the acquired graphic and digital documentation was carried out using Adobe Photoshop and Illustrator in order to obtain crucial technical information on the fabrics, following the standard parameter for identifying the basic structural element of the fabrics as shown in the slide. The investigation allowed us to document different types of weaves, the characteristics of the yarns, and to precisely calculate the number of weft and warp threads per centimeter. The most incomplete data concern the degree and direction of twist of the yarn. The former was impossible to determine reliably, whereas the latter was documented on only 6 of the plaster examined. Therefore, considering the peculiarity of the textile impression of the cast, the acquired data were processed to perform a qualitative assessment of the fabric impression using technical parameters. To compare the trace on the cast with the corpus of textile finds, the visual appearance of the fabric was also integrated, which proved to be particularly useful where the definition of the traces was lacking. On the slide, you have several examples of comparisons between the 2 classes of material, plaster cast and carbon textiles, which show how they are almost identical. It was very interesting to find on the cast mostly the same type of fabric with the same quality as that of carbonized textile, confirming the high level of standardization of the Vesuvian fabrics. So it was possible, of course, to infer the function of the carbonized fabric, but also to infer the type of fabric used to produce the textile that we found imprints of in the Egyptian cast. So excellent example of textile imprints and their comparison with the carbonized textile fragments are the following. So the first one of the nicer one is the plaster cast realized in Villa dei Misteri in Pompeii. So as you can see, there are 3 different textile imprints on the cast of good quality. And based on the stratigraphy on the impression, it was also possible to infer the function of the textile. So a tunic, a fabric belt, and then a mantle. Another interesting example is the plaster cast recently realized in Villa di Civita Giuliana, and we will see other interesting examples coming from this fine spot. So here it's a man that is wearing a mantle or a cloak, an overgarment, realized in twill. It's probably very heavy textiles, and it's almost identical in their appearance and also in the quality and textile structure of a series of carbonized textile made of twill. So we can also infer for the techniques and so the type of weaves and so on that also the imprints was from a wool twill textiles. And based on the stratigraphy under the twill fabric, there was another garment, most probably tunica, that is realized in tabby, in the face tabby. We don't know in what or west face tabby, and this is also remarkable. So it's a very fine quality impression, and we have similar carbonized textile made of bast fibers that are realized with this quality and with the same threads direction and so on. But moving forward, so on the slide you can see the Civita Giuliana site that is right outside the ancient city of Pompeii, so a few kilometers northwest of Pompeii, that provides new evidence of fabric imprints and textile fragments that testify the extensive use not only of garment, but also for utilitarian and tactical purposes. It is interesting that on this occasion, differently from the previous experiences, before the plaster was poured in the voids left by the bodies and other perishable materials, the investigation of the cavities were carried out in order to recover information for more exhaustive reconstruction of the archaeological data. So, as you can see on the slide, so photogrammetry was performed of such some evidence. The quality was not good enough. They decided not to use a micro lens for the recording and the photogrammetry of the evidences during excavation, of course. But as you can see, it was possible to realize the plaster cast only of some parts of these that are wooden beds. Some of the original imprints, as you can see, are visible and are still there. So in this occasion, it was also possible to do microscopic investigation on site, but also some fragment was on the ground, laying on the ground. So we took it and we did it in the laboratory. So in this case, was also interesting to have the possibility then to compare the original traces with the cast, and then the cast with the carbonized textiles. So what is interesting that no significant change in dimension between the imprints and the cast was recorded. And also we try to see with the scanning electron microscopy if it was possible to detect some organic remains on these imprints. In this case, was not possible, but it's remarkable the comparison within the carbonized robes we also encounter in the Vesuvian area. And in this case, we have like a 6 front round braids that is almost identical in the dimension of the carbonized one. And they are all realized in spartographs, so in priva denacissima. So it's highly possible that also the one impressed in the ashes were made also with the same material. And then, also regarding the two bodies found in the residential part of the villa, for the 5th time, before performing the cast, endoscopic analysis was undertaken along with the sampling of bone, textile imprints, and fabric residues. The inspections with the endoscope allowed firstly to ascertain the quality of the impressions left on the ashes, and secondly, to observe the osteological remains of the two male individuals, a young and an adult man. Regarding the textile evidence, some fragments of ash still preserving fabric imprints and textile residues were identified. All of them were recovered and documented in the original position and then subjected to microscopic and spectroscopic investigation. The discovery of textile residues made it possible for the first time to carry out laboratory investigation, but prior to this experience, it remained hidden within the mass of gypsum. In particular, the cast of the first victim, a young man, preserved imprints of a thickened folded fabrics on the abdomen, hips, and back. Based on their position on the body and their technical features, this evidence can be interpreted as part of the same garment, likely a wide but short tunica. This fabric has only one direct comparison in the textile collection of the Vesuvian area due to the Z-twist direction and the larger thread diameter. On the slide, you can see the carbonized textile with similar technical characteristics made of bast fibers. The microscopic analysis of small textile samples taken to the excavation confirmed the Z-twist of the yards. The opportunity to compare the textile imprints on the plaster cast with the extant fragment of fabric allow us to observe the visual appearance of the original fabric and, on the other hand, the degree of degradation of the organic material. The SEM analysis has shown degraded fibers that have entirely lost their original morphology. The investigation with energy-dispersive X-ray and FTIR give preliminary insight into the type of mineralization of the fibers due to the mineral content of the pyroclastic material, whereas the spectroscopic analysis added information related to the presence of highly degraded organic compounds. For the research is needed, of course, but the peak and stretching bands detected suggest the degradation of cellulosic fibers. So, lastly, we'll consider the techniques and methods used enable the investigation of imprints, allowing for proper documentation of all textile evidence in terms of their technical characteristics, even make it possible to establish comparison with the extant carbonized textiles. Although affordable, the process was time-consuming, especially given the on-site work and post-processing measurements. Digital techniques could help overcome issues by enabling movement in a digital environment, making it easy to investigate not only garments, but also textile imprints. In particular, photogrammetry can record finer details than laser scanning, and although acquisition will still be time-consuming, it will speed up research because the digital replica will be directly measurable. As Agata already said this morning, early this morning, the 3D acquisition, so the digital replica of the plaster cast from Pompeii, the Vesuvian area, will be performed using some key studies within our shared project, Textiles, And you can see here some details of the project and the consortium as well. So the project focused on digitalization of archaeological and historical textiles, and cultural and technical partners are deeply involved in developing new tools and strategy for the digital study, dissemination, communication of textile heritage, and also the use of AI. So I will show you briefly some of the preliminary outcome we had with photogrammetry. And I have to tell you that it's, in my opinion, a compromise between the three-dimensional view and a high-quality detail. So, and maybe can help in have also a standard in documentation as well of imprints. But of course, I have also to say that with a medium standard digital camera, with a micro lens, a single picture was highly detailed than the photogrammetric resolution. So these are the two plaster casts from the Città Giuliana villas. And these are part of the folded tunic of the first victim. And yeah, you can see here, even though you have had few folds and so on, so the quality is pretty good. I mean, it's a compromise. And this was a close-up of the mantle of the other victim, in two twins. So here, because the quality of the impression of the textile is very, very good, you can still see the thread direction. In this case, with your naked eye and just a single macro photograph, you can see it. But with photogrammetry, it's not that good. If you don't know, if you can see with your naked eye the object, you would not recognize it on the photogrammetry. But anyway, I mean, it's a good start, more than expected. So thank you very much. Thank you.
Okay. Any questions, either in the room or in the arena?
Now, once I understood you could sometimes match the actual carbonized fabric and the imprint of the plastic cast. For example, for this fabric, can you say the shrinkage, the difference between the in thread count and in thread diameter between the imprint in the plastic cast, which should be the original state of the textile, and then the carbonized one, which maybe has some transformation because of shrinkage, because of the heat. Did you observe things like that?
No, I actually could record the same thread counts, the same dimension of the thread and so on. But I would say in some cases, study the carbonized textile, you can see the shrinkage, the low dimension of the thread because of the carbonization, but in most of the cases, the state of the fibers is really good, even though the carbonization. So yeah, we would never know the exact shrinkage or so, but I would say that they are pretty the same in many cases. So I think also in original, so they will be
They can from the same context then, otherwise you cannot match.
Sorry?
You can just match them if they come from the same context. Body.
Ah, okay, yeah, no, of course not. I don't infer this.
There is a question in the chat from Anna Decker. Did you find any impressions of subs?
No.
I'm sorry. And I have also a question for you, because this context thinking for me is quite crucial. So I understand that the find from Città Giuliana, they are like, it's the same context of the Gibson cast and the finds, but what about the others? Are they from the same archaeological context?
Or all the other plastic?
Yes.
I mean, no, they are scattered in the ancient
Yeah, but
city.
I mean, when you find parallel, is it carbonized in actual?
No,
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 that's
no.
not actually.
And that, yeah, it's important to say that the majority of the carbonized textiles from Pompeii are without context because the excavation were undertaken in the 18th century and 19th century. This is a huge problem. We also have some general information about the find spot, like house of or near the.
But for this Juliana, it's like.
Yeah, Juliana, yes.
Great, that's impressive. Because it's like hard evidence.
Yeah, they are not carbonous, they are just degraded. And so you know also exactly of which part of the body they are coming from. So, yeah.
That's amazing. Are there any more questions for Francesca? Yes, Maria, of course.
Thank you very much. I also learned a lot. It's a really interesting topic. I have a question that's not related to textiles, sorry, and I don't know if you can answer it. But since you were, you had to study the cast yourself, I wonder whether you have any idea whether Pompeii has probably this preservation of these casts. Because we have them, they are kind of modern, but they become archaeological objects for us.
Yes.
And I saw one from there and that you showed, he was missing a leg. I don't know if he was missing a leg anyway.
No, because the leg was underneath the other cast. Because so you have the voids, you put the gypsum there, and so you got what is there. So if a leg is under or above another, so you miss part of the original shape of the object or the body. That's the reason why. But of course, the plaster cuts that were made 2 centuries ago, some missing parts probably are missing because they lost it at some point, so they were broken. But like some years ago, there was a huge work to recover all the casts in the museum there and the one that were in the original find spot. And a huge restoration activity was undertaken. So now they are all complete, well restored. I mean, they did a huge work. But the problem is with the new one, because in some cases they leave the cast with some of the ashes on it. They decide not to remove the ashes during excavation, and that makes problem then on the gypsum surface that become black and yeah, some degradation occur. I don't know why, but for the historical cast, yeah, so there are no problem anymore thanks to the restoration activities.
And more questions? We keep it for discussion, and now we will invite Aldona Kurzawska from the University of Administrative in Poznań.
Thank you very much for the invitation to this workshop. I will present partially scanning electron microscopy and used in the studies of textile imprints, but also I've added to my presentation the digital microscopy PNs that we use in the lab. And I think this is also important because at least in Vienna, we have exactly the same microscope, and also at the University of Warsaw, we also have here the MENS microscope, and it has some important functions that might be also useful for the studies, for the analysis. So let's begin how to make the presentation. The arrows are not working. Okay, so.
Just click one on the.
Yeah,
one click on the screen. Yes, and
Yes, okay, now.
thank you.
Okay, so the sand is usually or traditionally used
for imaging and analyzing the surface of materials with high resolution. In SEM, a beam of electrons is generated by an electron gun. Electrons are accelerated under vortices of about 1 to 30 and focused into a narrow beam by electromagnetic lenses. Scanning the sample. So the focus beam is raster scan across the sample surface. The interaction between the beam and the sample generates various signals that are detected and used to form an image. Several signals are usually produced, but the most commonly used are the secondary electrons, so SE, that will provide detailed topographic images of the surface. And the second one, the backscatter electrons, so usually called the BSE, depend on atomic number used for composition of contrast. And characteristics X-rays or EDS or EDX allow elemental composition analysis. So in my presentation, I will focus on those two because these are the most useful for the imprints that we would like to see. But for these studies, as far as I understood, for the imprints, I think the SE images are the most useful ones, and I will present why. So the types of samples that are suitable for SEM. So basically the conductive materials like metals, alloys, semiconductors, they require minimal preparation. So these are the most easiest artifacts that we can do on SEM, do the analysis, to see the microstructures because they are conductive materials. So the non-conductive, they will always cause problems. To get the best pictures, it's sometimes really hard, time-consuming, and those are ceramics, plastic, dry, clay, glass, minerals, biological tissues, and usually they must be coated with conductive layers like gold, platinum, or carbon to prevent charging, because charging will cause our image to be really bad. So there are some exceptions, of course, and the semiconductive artifacts that cannot be coated, we have artifacts from museums, we cannot cover them with extra layers, yeah? So usually we do still try to obtain images. So those we can observe using the BSE image on the low back, but the image sometimes is of poor quality, this I can say, and it's really hard to get pictures sometimes. What is not suitable for some liquids or water-containing samples? Beam-sensitive materials may degrade under the electron beam. So these are the basic information. So in the case of the imprints on clay, we have those non-conductive materials, unfortunately. So I was trying to solve the problem, how we can prepare the samples, prepare the pottery, or how to get a proper image to investigate the microstructure. So in summary, if we want to get topography, we use secondary electron SE images, the detector, and it's always high resolution surface imaging, but only on conductive samples or those that were coated. And here you can see the beautiful picture of flux. The sample was prepared, it was coated by gold, so the picture is quite good. And when we want to invest morphology and we have semi or non-conductive samples, the BSE is used, and you can already see that the picture is not so good, but still we have the image. But with the microstructure, we will see cracks, surface irregularities. So it won't be really the pictures you want in the case of imprints. Yeah, because in the imprints, we want the microstructure, so the topography. In 2021, I was asked for the first time to check the pottery on sand. And these were the imprints of the Bronze Age period, the ones that you can take a look. Here it was the PhD studies of Weronika Skrzyniecka, also Professor Makarowicz and Patrycja Silska, they took part in this project. And I was asked if I can take a look if the images will be good enough to recognize some details that they couldn't see on the regular pictures. So this was the first picture I took on sand, and I was like, okay, I see pottery. And of course, because this was the pottery fragments, I could only use the BSE images. So for me, the quality was just, there's no point to put the pottery inside. So the pottery fragments with imprints, yeah. But I was, yeah, a second one. But still, I was trying to solve the problem. And since then, I was thinking how we can use sand for this. And my idea, yeah, again, the pottery. Here you see the Kian's picture, and it's much better than sand. And lower magnification, it's just better. So for the pottery, I think when we investigate the fragments, the keys will be the best. Later on, I will show you more photos made recently. But with the sand micro photographs of the pottery, yeah, I was so disappointed, and I was still looking at methods. And because also, usually I work with ornaments, and these are my basic studies. And for the ornaments, we are sometimes using a silicone cast to see the drillings inside the bead, for example, or pendants. And benefiting from my experience in this with the silicone cast, I try to apply this method to examine the textile imprints on pottery fragments. And here you can see how it looks on sand. And with sand and the silicone cast, you always use the low magnification, but the details of the perforation, like here on these pictures, you can really see how the drillings was done. So I thought maybe we should use also the silicone cast for the imprints on pottery. So I've given it a try, and this is just the random pottery that I found in my office, or my colleagues gave me at the faculty with some port imprints and also a piece with the textiles. And again, I was disappointed, but not entirely, because the silicone made those fat traces. And I was really like, wow, what's that? And but still, okay, I decided to keep going. And I made those casts, then I clean it. Already Agata saw the process of making it. And it looks, this is the pictures from the Kians. It looks more or less like that. Also, with the Neolithic pottery or in the Bronze Age, the surface of the pottery is usually very rough. So with the silicone, you're taking off also pieces of pottery. So this is not nice at all. But then Agata appears and she was like brushing my silicone cast, so it improved a bit.
I know it thanks to Maria.
Yeah. So yeah, they were brushed a bit. And as a next step, you have to know that this is extremely difficult when you have a silicone to attach the silicone to the carbon tape that is used on sand. You have to put something there. So my idea when I started with the ornaments was, okay, so it's so slippy, the silicone, how to attach my sample? First to hold the sample by gold and then to put it into the sand. And I was like, oh, okay, so I need something that I have inside the silicone. So I found out I can use those toothpicks for that. So this is like my addition to this silicone cast. It looks weird. I have all those samples would be. So later on you can take a look. Yeah, they look a bit funny, I think, but it works. So my first attempt, I put uncoated silicon samples into the SEM. So we may expect that because it's non-conductive material, the pictures were not nice. This is the pictures. It's completely, you don't really see the structure. So yeah, I decided that I have to coat the samples, another picture of it. And yes, and because we have the coater that used the gold, so now they are more precious, I think, with the gold layer on it. So they were coated, and then I got a really good images. And now I will show the pictures that I took. With SEM, for sure, we have to use just the lowest magnification we have on SEM. So this is not the traditional use of SEM, but the pictures, I think the quality of them are really nice. And from your experience, you can tell me if the microstructure is good enough for your research or not. So these are some other pictures. Yeah, I was taking pictures just to try what I can see, if I can see the single fibers or some details in the threads. And these are the textiles already. Pottery. So I tried different options. Yeah, well, go back. How to go back? No, let's now move forward. Yes, so the use of the digital microscopy, because usually we don't have SEM or we don't have access to them, or it's expensive to do this. Because we have at the faculty SEM, we can do this for free, so it's just time consuming for me, but yeah, the results are okay. But if we want to use the keyens, and we have pottery fragments. Also, this is good to know that we have this option. Of course, both methods are not mobile, so this is a disadvantage. But if we have the casts done somewhere else, we can also work with the casts. It's not a problem. And when we conduct the observation with various microscope configuration, in the keyens, it is called optical shadow effect mode, and I think it's similar effect to the RTI, because it also takes pictures using different light, direction of light. And here you can see the results are like this. So these are the pictures from pottery. And also you can do this colorful model if you wish. And also those. So you can like convert, instead of negatives, you have positives. Yeah. So keyens also works quite well. So more pictures, and of course here you can see this ugly trace left by silicone. And again, casts. And of course, I put also this silicone samples that I took. We can also take the measurement. Also with SEM, we can measure everything, what we want. Also, we can do the mesh if we need the density of the textile. So with the keyens, we can work both on the pottery fragments and also on the silicone cast, and I think the results are also
Very nice. And also, I had one like positive cast because Andrzej Sikorski, he left some, and we still have his documentation. And I tried with the clay because I didn't have time before this workshop to use different materials than the silicone. So still, I think I have to try also with the SEM and also with the TS, but I think the results would be also similar. Yeah. Just we have to keep some small if we want to put them on SEM. So for the conclusions, for positive casts, silicone, foam, or clay, optimal imaging is achieved with coated casts using the SE detector in high vac mode at low magnification up to 100, but I think 50 is just enough. For pottery shards with textile imprints, digital microscopy using the TS is in optical shadow effect mode is recommended, not SEM. Positive casts made of clay should also be examined with the TS using the optical shadow effect modes. The visibility of the details on casts, silicone, foam, or clay under SEM should be carefully tested, also with the experiments. Because I think that maybe we'll see some differences. I mean, if we will use a thread made of wool or bast fibers, we should see the differences in the imprint on SEM and on the keys. Based on my experience in SEM, it is generally not the most suitable method for observing pottery shards. Just the images are just really bad because it's non-conductive material. And with the digital microscopy, we will have superior results for pottery shards. And it will allow the detailed observation of surface textures and texture or tool imprints without damaging the sample. Of course, measurements are possible on both the SEM and the digital microscope. Just the one disadvantage, this is not mobile. Yeah. Okay. So thank you very much.
Now questions, Karina.
Yes.
Thomas.
Yeah. Comments. Especially for example, complete vessels. Of course, the clearance is wonderful because you can move it around and so on. And this is also a limiting factor for what type of microscope or whatever you use is always the material as always. I mean, the plaster casts are very special again, but the pots, the full pots, if you have just flat material, you can play around much more easily, but even in SEM. We have quite good results with my projects in SEM, but I did not know what the operator did. I will show you afterwards some images that he did, but I don't know what exactly he did. But it functions somehow, and he did not code. This was about what are you doing with very three-dimensional things like complete pot. How do you do that? So,
You need an arm to the microscope. That's the basic stuff. I mean, if you want really do the proper images and you have a complete post, I would do for sure the casts, the silicone casts or the clay casts to put under the microscope. Or if you have additional arm to the microscope and you can move the objective forward, then we will have like the possibility to do the pictures also on the large objects. So it depends what kind of equipment you have in the lab. Yeah, because with this arm and the objective that can be moved, it's possible. PS also has these functions.
You would really recommend to do just a silicone cast. Would be good in your opinion.
I mean, yes, because if the silicone is of good quality, also the clay, because already you've had those experiences, yes, but you can see the details. So I think it's okay.
Okay.
And cheaper than to buy additional equipment to the microscope or the microscope. That is very expensive.
Definitely cheaper than PS.
Yeah.
Any other questions? Are there any precautions, thanks, and regulations regarding cleaning the ceramics during imprints right after coming of the field in view of this documentation? Inka, do you want to say something about it? No. Yes, I mean, we have to clean to have it really cleaned. It could be used like brushes, for brushes, or not like the makeup brushes, which are not like big brushes, but tiny brushes, because that's more of the microstructure on the pulp that we have also be aware, especially like for the, let's say, Central European finds that we may have incrustation. And then removing the incrustation from the core imprint is not the most desirable thing. So again, it's very much, I would say it's very much object specific how to deal with it. But yes, for like for the readability or legibility of imprints, we need to clean the object definitely.
And also, I think when I tried with the silicone, so my first try always took some dirt that I was not able to clean from the pottery. So I used this second cast for the certain bottles. Because already the first one looked like clean and then
it's like a peeling.
Yeah.
I think we will have a chance to experience that. I don't know, Sophia, this is like planning well enough what you've been asking about, perhaps yes. Are there any other questions? If not, then we will make a break, a lunch break, and we will see Agata online and you will stay like in the room, but we will see again at 2. Thank you very much.